Hello everyone, today we will be building a logistical regression model. This data is collected from Kaggle about the solar radiation in Hawaii, USA. Now, a dependent variable here is the radiation, with 800 being the cutoff, and the X variables are pressure, humidity, and such. This data is already clean, but if you need to clean it, go to Power Pivot, manage, and clean it through Power Query. Moving on, we will be converting it into encoded binary variables. The threshold for those variables is shown here. Let's go. I'll show you an example how I did it. And temperature, again temperature, multiply it by 1 to make it into binary. Pressure, for this we will use the if function because there is only one logical function to be had. Binary encoding is done. Okay, now let's do the split calculation. Equal to counting. Here we have also included the y variable in the table. Again, countess, we will use the same range as the previous time. Okay, 70-30 split between training and test set. Zeros and ones number is given here. So we remember to make it into a table. We use these functions. Okay. Control C. Go to the extra sheet we have opened. Control V. Right here rand. If you don't give any value, then the value will automatically be within 0 and 1. Go to data, sort by rand small to largest. Okay, say 2208. Okay, this one has been done for this. Now let's move on to 0 now. This part is for the test set. Control B. Done. Now let's return to the encoded binary. Move to the top, make it select to 0, deselect the 1. Okay, done. Move to the left, select the whole thing. Control C. Another open sheet you have. Control V again. Rand function. Go data, sort by rand smallest to largest. Okay, done. Now select till 2208. Okay. Control C. Can you download it? Go to the bottom. Control B. Done. That's it again. Go to sheet number 2 again. Delete this part and Control X. Go to the top, paste it, and this one was A4104. This is for the test set. Okay. So 4104. Go to the test set. Go to the very bottom. Control B. Done. Now training with data variables. Let's go up. Select this whole thing. Go to home. Format as table. Format it as a table. Okay. Home. Then no cell. Done. Now we will add something. Linear combination. This one is probability This one is log likelihood. Okay. The formula for linear regression is sum product. The ranges are first of all this except for the high radiation, then this except for the intercept, but you have to log this one. Be sure to remember that. Close it plus the intercept. Also log this one. Done. Now the probability is equal to 1 divided by 1 plus exponent of minus linear combination. Okay. Log likelihood is equal to high radiation into ln of probability, close the bracket, joint it, again bracket 1 minus high radiation, then close the bracket, multiply with ln of 1 minus this one. Okay. We will find out the sum of log likelihood. This is the log likelihood here is the sum of square error. Okay, and we want to maximize this, and we will do it using the solver. Select this by changing the variable cells. The variable cells here are this. Okay, subject to constraint, add, then this is equal to less than equal to 5. Again add this part as well. This one will be greater than equal to minus 5. Okay, so all the things are in place. It will be evolutionary. For the option, we will go with 100. Okay, now let's run the solver. The solver has been done, and we have got these variables. This model quest. We will copy it, and then we will paste it here. Let's continue. Again, there will be the linear count, then the probability. We are using a sigmoid function here. Information from product of the range. Here. Okay. Let's go with this one. Let's look at the intercept. Lock it. Plus the intercept. Also lock it. Okay. The probability. Let's go with this one. 1 divided by 1 plus exponent of negative linear combination. Done. Okay, we will define, sorry, not this one. So we will define this as P for little convenience, this one as Y for little convenience. Now let's move on to performance. Okay, so performance, the maximum value will be of P, and this one will be minimum of P. Step will be 0.01. Let's say for this one, cutoff will be sequence. The rows will be this minus this divided by columns will be 1. The start value will be this, and the step value will be this. Okay, done. Now for the true positive, we will use count-if function. Okay. The first criteria range will be the y variable. If it is 1, then will be the p variable. If it is greater than equal to greater than equal to this. For the false positive, this one only the y will change, it will become 0. As true positive, we will similarly fill all of this. True negative as well. Control V, then negative will be less than, and this one will also be 0. Control V, this one will be less than, that will be 1. Okay, now the TRP rate, this will be this divided by summation of true positive plus false negative. Break down, this one will be false positive divided by false positive plus true negative. This one is also break down. Now we will create the area under the curve. The area under the curve follows the trapezoid formula. This minus this into 0.5 into this plus this. It means that the area under the curve will be 87%, which is quite high. Now let's select this. Go to. We will make the curve is done. Now let us move on. The confusion matrix we will be making here. Take a random cutoff value, 0.607, let's say. Okay, now we will determine the true positive value for this. We will use again count if function. Count if it will be the criteria range is P or probability. If it is greater than or equal to this and y is also 1. Do it true positive counting. Okay, so we have made the confusion matrix. Now let us move on. Here our goal is to maximize the F1, and by doing so we will be able to find out. Now for the recall of sensitivity, that is if where it will be equal to true positive divided by true positive plus false negative, sorry. Okay, and the expression will also be true positive divided by true positive plus false positive, and this will be equal to twice of this into this divided by the summation of this and this. So this is the value. We can express it in percentage if you want. Our goal is to maximize this by changing the value of this. For that we will use solver. I'm not showing now, but I have previously shown you how to do the solver. This will be the value which will be changed, and this is the value we want to maximize. Thank you.